We're here today at the Yamazaki Mazak Technology Centre in Worcester. A fantastic facility where we're exhibiting at the GTMA technology event. We've got our latest demonstration vehicle here, which is a conveyor set up to show the coolant saver and the oil saver in action, which really replicates the environment that the coolant saver will be used in the machine shop. So what we have here is a conveyor that's rigged up very similar to what a conveyor would be on a machining centre. Apart from we haven't got the machining centre, it's just the conveyor. So we've actually got a pump on the rig, which would be typically your round spindle pump, or a pump that's used to power the coolant going up into the machine. So this is generally a pump that will be on while the machine is on. Right, we're going to go run through how the coolant saver is connected onto the demonstration rig here, which is replicant of the machining of a conveyor, or a pump on a conveyor. So this would typically be a round spindle pump here, and what we're doing is just taking a small feed from the pump through the coolant saver, which is just teed off on the main line, which would typically be your round spindle or main coolant line. So it'll be a pump that's on the majority of the time the machine's on. So we'll have a small flow. We've got a regulator gauge here that will go through the nozzle system and then back out through the outlet hose and then back into the sump. Now that is what's actually powering the unit. So that flow through there creates our sideways suction there. As you can see there, it's pulsing because we've actually on a demonstration rig here where the coolant is being collected and brought back round into the unit and then back through there. So this is all done automatically. So once it's installed on the machine, the coolant, this can be left on and can be basically not actually touched by anybody because it's on all the time. We've also got on here is the coolant saver. So we've got the coolant saver here and the oil saver really do the same thing, apart from the oil saver has been designed for sliding head machines and neat oil for lower power rate pumps. It won't be as fast to reclaim, but it will be still enough to keep up with the drag out of the machine. Okay, so we can see here, this is the filtered vacuum cup, has a non-return valve in here. Now this part here is always going to be on while the machine is on, so it'll always be sucking. So we place that into the swarf in, and we'd usually typically put that inside a fabrication, a steel fabrication like this. And as soon as it hits, the bin comes into the conveyor, ready for a new empty bin, ready for collecting of the swarf. The coolant, as you can see, is trickling out from the conveyor. This will collect that fresh coolant, return it, and bring it straight back into the sump of the machine. So the fresh coolant is going straight back. So we're saving an awful lot of coolant, neat oil, and also all that disposed coolant that goes out with the swarf, that will be a minimal amount that goes out in the swarf. So this is all automatic, it's powered off the machine, so it requires no external energy, and it's continually working while the machine's on. So all anybody's got to remember, once you're all installed, is to put the vacuum in and out the bin when it's in action. So in conclusion, coolant saver can give us some fantastic benefits. With up to 50% coolant saving through reduced topping up and wastage. Obviously the swarf value goes up with less coolant in the swarf. The biggie, up to 90% disposal savings, reduction in disposal to remove the coolant, improved housekeeping, cleaner air around the swarf bins, manpower reduction, the system works automatically, so there's less having to drain coolant from the swarf, and really a key one to finish with, which is becoming a biggie, is the environmental side, because we're recycling, reclaiming good coolant back into the machine and reused again.